Turn the lights off. Okay, we're recording. All right, so far we've talked about systems. Yep. So far we've talked about systems with how many different variables? 2. What were they called? X and Y. Okay, so today we're going to start talking about some things that have 3 variables, X, Y, and Z. And so if I gave you something like this, well, yes, because I'm going to start with something that's real basic, and then we're going to kind of work back and say, how do we get there? Okay. So I have X minus 2Y. Settle down. What's the problem?
Probably thinks that you're trying to go there.
Okay, X minus 2Y plus Z equals 7.
Oh, those are different equations.
Yep.
Okay.
Yep. These are 3 different equations. Okay, so if we had 3 lines with X, Y, and Z, and I had it written like that, how could you figure out what the other variables were? Okay, yeah, so this is solved for Z. I could go back and plug in Z up there, so let's do that. Okay, so what would Y equal?
Yeah, 2.
Is that hard to see? Okay. Yep. Hold on, guys. I'm going to do with marker, I think. It's distracted. Okay. Who called it first? Okay. You can get a Jolly Rancher. All right. So what would that change my answer to? Yep. All right, so now I know X and Y. Can you see that better now? Okay. Now I know our Z and Y. What could I now go do? Plug it back up here. So now I had X minus 2 times negative 1 plus 3 equals 7. Okay, can you find X a second for me? You're welcome. Tobin? X equals 2. Okay. So when we're solving for 3 variables, instead of like an ordered pair, we write them as an ordered triple. And the ordered triples are X, Y, and Z. So we would write this as 2, negative 1, 3. Okay. So would you agree with me if I could get, let's say I had 3 rows of 3 variables, if I could get it to look like this, that would be not too bad to solve. Just involves substitution. Okay. We call this, now it's not a real triangle, kind of. We call this triangular form. Okay, and so our goal today is going to be to get these things into triangular form. So that's why I showed you that first, to show you that, you know, once we get to triangular form, we can just back substitute to find everything else. Okay? I don't know. You'd have to talk to Friedrich Gauss and ask him. And I think he's deceased.
Probably if you wind up the 7, 3.
Yes. Technically, if you looked at like just this side, Cole, the left side, that would be a triangle, right?
Yeah.
Okay. All right. Yeah, sure. Let's talk about Gaussian elimination, because this is going to be the process we're going to use to get our systems into triangular form. Okay, so here are the rules, I'll say, for Gaussian elimination. Number one, at any time, you may interchange any two equations of the system. Number two, you may multiply or divide one equation by a non-real, non-real, that's not what I meant. Then it wouldn't be real. Non-zero real number. Okay, haven't we done this so far with elimination? Like we will multiply, remember we multiplied an entire equation by something to get them to be opposites, to get things to cancel. Do you remember that a couple days ago? Okay, so that's all that thing. And then number three, you may at any time, and again this is nothing new, add, I would guess, or subtract two equations. And we did that with elimination as well. But the new thing is, that new equation that we get, we may then substitute for any row. What do you think, Mr. Costa? No.
How we just walk in and walk out with no mention of anything.
He walked in all yours. I was like, okay, let's start some notes.
And then Nicole was like, sure, this is no good.
Okay, that's okay. It's not scary. Just act natural. Okay, we're recording. Let's stay on task. So, I'm going to give you a system then. So the system I'm going to give you is I will. We're going to do this one, and then we're going to pause, because we might do some more, but that at least will give you the gist of the lesson. We're going to do x plus 2y minus z equals 3. (3x plus 7y minus 3z equals 12. And negative 2x minus 4y plus 3z equals negative 5. Okay. And then let me tell you my my strategy here, and you can use any of these three things we talked about. But remember how my goal was to get to triangular form? So what I try to do first is do the bottom row, and here's what I do, okay? I try to get rid of x in the bottom row and x in the middle row, and then I have y's and z's in left, and then I try to get rid of the y down here, okay? So I'm going to always write what I'm doing. So what I'm going to do first is I'm going to get rid of x down here. So couldn't I multiply the top row by negative 3? Okay, so I'm going to do that. I always like to write down what I'm doing right above because it's a lot of work. So I'm going to do negative 3 times row 1, and I'm going to add it on to row 2. Okay? Alright, What's negative 3 times row 1? 12.
Negative 3x minus 6y plus 3z, or plus 3z equals negative 9.
Do you guys agree with that? And then row 2 is 3x plus 7y minus 3z. Ooh, we get a 2 for 1 here. All right. Normally that doesn't happen. Okay, we're going to now add these two together. What's negative 3x plus 3x? What's negative 6y plus 7y? And this is 0. Yikes. That doesn't normally happen. Y equals 3. Okay. Okay, I'm going to sub, just so you know what I'm doing, I always like to do replace it back in. The Y row is the second one, so I'm going to put that back into row 2. And so what I now have is this, I'm going to take out, and I'm going to put Y equals 3 in there. Okay. And I like to line up my variables because I'm weird like that. All right. So I have 0 z's. Okay. Now, let's look at the top row and the bottom row. Let's work with those two equations. I think he laughed when he heard Gaussian elimination. Good thing he's not a math major. Mr. Goff. He's probably like, whoa, Gaussian elimination.
That sounds like an old time.
Yeah. How can you eliminate x in row 3, guys? How would you do that? Okay, 2 times row 1 plus row 3. Do you see that? 2 times row 1 plus row 3 would get rid of the x in row 3. So I have 2x plus 4y minus 2z equals 6, and then negative 2x minus 4y, oh, I'm going to get another 2 for 1 here. I didn't even plan that out. Plus 3z equals negative 5. So I just simply rewrote row 3. I didn't do anything to it. All right, add them down. 0, 0, z equals 1. Huh. I'm going to put that back in for row 3. Now, at this point, oh, need white out, 1. At this point, if you did not eliminate, you might need to do one more step, okay? We happen to get 2 variables to cancel out, but if you didn't, what you would be able to do is use these 2 rows to eliminate that, okay? But since we did get 2 for 1, it's very nice. It saves us a step. Then can't I solve now at this point? Yeah. Because I know z equals 1, and even if I had a y and a z here, I could have still solved at this point. So z equals 1, y equals 3. Let's go back and find x. X plus 2 times 3 minus 1 equals 3. So I'm rewriting that top row. 6 minus 1 is 5, right? So x equals negative 2. And then,
square root.
What?
Also minus square root.
Oh.
B, whatever.
So this would be the solution. Now, just like before, guys, a solution means that if you put x, y, and z, these values into any 3 of those equations, they would make them true. Okay.